Hello everyone, this is Linu. Welcome to Lenvis. Hope you guys are doing well. And last video we discussed about chemical kinetics, right? So we will be continuing that topic in this video. That is, we are going to discuss about integrated rate equation for zero order reaction and first order reaction. Okay. Yes, and we have discussed about the difference between order, molecularity, etc. in the last video, right? So make sure you stay till the end of the video. You get some amazing tips and tricks, and don't forget to hit the subscribe button and ring the bell icon so you will never miss an update from us. Okay, now let's get started. Yes. So integrated rate equation for a zero order reaction. We know what is a zero order reaction. That is the rate which is independent of what? That is independent of the concentration of the reactants and the powers are zero. That is called zero order, right? Yes. So this is zero order reaction. So rate is equal to K, rate constant, A raised to 0. And let us consider the reaction A giving B. How will you write the rate of this reaction? Rate is equal to minus, in concentration of reactant terms, minus d by dt of concentration of A, that is equal to K, A raised to 0. What is A raised to 0? This is the rate formula we know, and this is equal to this. We are equating both two equations, okay? And we know A is equal to 0. So you can write like minus d by dt of concentration of E is equal to K. Okay, K. A0 is equal to 1. Also you can write what? Concentration of A is equal to D of A is equal to minus K dt. This is derivative, right? So we have to take integration on both sides in order to remove that D. So after integrating, you will be getting what? A is equal to minus KT plus C. Okay. Let it be the first equation. Now, what is C? C is the constant of integration. Constant of integration. And let imagine when T is equal to 0. T is equal to 0 means what? Concentration of A is equal to what? A is equal to Z, right? This will be equal to 0. And we also know when T equal to 0, initial concentration is equal to what? A. Okay, so we can substitute this in the equation. A is equal to minus K T plus A0. Okay, so this is the equation. What is K? Then the K is equal to A0 minus A over T. This is the final equation for the zero order reaction, right? Constant K is equal to initial minus final by T. Okay, hope you get it. Understand how it is coming? Now we have to plot some graphs. Okay, so first graph is, let us plot it. Graphs are very important. Concentration of A against T. Against T. What is our equation? K is equal to A0 minus A by T. This is our equation. We are going to plot A against T. Okay. That is, our equation will become what? A0, A is equal to A0 minus KT. And this is in the form of a straight line y equal to mx plus c. We are plotting this A against K, right? A against T we are plotting. A against T time. So we'll be getting a graph like this. Negative slope. This is the slope. M is equal to slope here. Minus K is the slope. So you'll be getting a negative slope. Here A. Here time. Okay, negative slope, and the slope is equal to minus k. And C is the intercept, that is A0. This is the intercept A0. That is this point. This point we call it as A0. Okay. This is the first graph where A is plotted against a what? Time. Okay. Next, we can draw a plot of the rate of the reaction. Rate of reaction against time. Okay, T. That is, let us draw the graph. Rate is against time. What is happening? This is a straight line parallel to x-axis. Straight line parallel to x-axis. So these are the two important graph of zero order reaction. First of all, you must know how this integrated rate equation we are doing. First of all, we know it is a zero order reaction. So rate is independent of the concentrations raised to power, right? Zero. And we know this rate equation, and when the reaction is A to B minus d by dt of A, we are now equating them. So we'll be getting some equation, we have to integrate them. After integration, you'll be getting a C. After that, when time equal to 0, you have to find the C value. So you'll be getting the integrated rate equation for this zero order reaction. Now we will do the integrated rate equation of a first order reaction. First order. Similar way we are doing, okay? Since it is a first order reaction, you must know, just take the example A to B also. So the rate is equal to what? K times concentration of A raised to 1, right? Because it's a first order reaction. And which is also rate is also equal to what? Minus d by dt of concentration of A. And we get the two rate. So we have to equate them, right? K times concentration of A is equal to minus d by dt of concentration of A. Then in order to take this is known as the differential form. Okay, after rearranging, you will be getting what? K dt. Okay, K dt. I bring this dt to this side, A to this side. Okay, K dt is equal to minus d by d d of, okay, sorry, minus A by A. Okay, that is equal to K dt. You will be getting that. Now you have to integrate. Okay, integrate. We have to apply some mathematics. Okay, so integration on the both sides, you will be getting what? Minus ln A. Ln concentration of A is equal to Kt plus C. Where is C is the constant? Okay. Okay. When we have to find C when time is equal to 0, means what? Minus ln A0 is equal to K times 0 plus C. So you'll be getting what? C is equal to minus ln A0. Then you have to substitute this C in this equation. You will be getting minus ln A is equal to Kt minus ln A0. Taking along the both sides, you will be getting ln A0 minus ln log. Ln means logarithm, natural logarithm is equal to Kt. Okay. Log A minus log B what? Log A by log, not log, log A by B. That is equal to Kt. Okay. You have to remove this integration, sorry, a natural logarithm to the base 10. You will be getting Kt is equal to 2.303 log log. Now it is changed. A0 by A. This is the final equation for the integrated rate equation. You can write this in the form of K is equal to. Okay. This is the first order reaction. Okay, how will you write? K is equal to 2.303 by T log A0 by A. This is the integrated rate equation for the first order reaction. And you can plot this in terms of what? In terms, there are so many plots possible. Let us discuss one by one. Yes, you can draw like log A, okay, log A versus time, okay, time. Okay, what is the equation? We must know the equation. We know the equation K is equal to 2.303 by T, okay, log A0 by A. Okay, this is our integrated last equation. Okay, before that we had one equation. Before reaching this, we had one equation. What was the equation? Log A0 minus log A is equal to KT. This is in the form of y equal to mx plus c. Okay, if you take this to the right hand side, you will be getting log A. You have to plot log A. So that is equal to log A0 plus KT. Okay. And in order to, there is no 2.3 here, right? So you have to put it 2.3. You are taking this to this side, so it will become positive. And KT you are taking to this side, so it will become negative. Okay. So you have to consider the negatives, and because the slope is negative. And one more thing you have to remember here, what? You have to multiply it with what? 2.303, because this was initial natural logarithm. You have to convert it into logarithm in terms of 10. So you have to divide, okay, 2.303. When you plot log A against T, what do you get? You will be getting the graph like this. Log A against T, a slope, negative slope. What is the formula of the slope? Is equal to minus K by 2.303. And what is the intercept? Intercept is log A0. Okay. So this is the one of the graphs of what? First order reaction. Okay. So one more graph we can draw, that is log A0 by A in the x-axis and time in the y-axis. Here you will be getting a positive slope. What is that slope value? Slope is equal to k by 2.303. That is, we can consider the equation in the last integrated rate equation, right? That is k t is equal to or you can write kt is equal to 2.303 log A0 by A. This is the equation, right? When you take 2.3 to this side, you will be getting what? Log A0 by A is equal to KT by 2.303. This is also in the form of y equal to mx plus c, where c is equal to 0, only m. M is there, m is k by 2.303. Okay. So this is how we are plotting the equations, plotting the graphs using the equation. So this is the second equation. Okay. Hope you understand how to find out the integrated rate equation for zero order reaction and first order reaction. I will explain once more, very important. And that is, first of all, what you have to do? What you have to do is you have to equate the rates formula. Okay. First of all, for the zero order reaction, you know rate is directly proportional to reactance. Reactance raised to 0 because it is independent of the reactant, right? Yes. So that equation you have written. Now the average rate equation minus d by dt, that is minus in terms of decrease in concentration of the reactant, and after that you have to equate it. Okay, after equating you will be getting the integrated rate equation. Okay, after that what you have to do? You have to integrate in order to remove that d. Okay, you have to take that integration on both sides. You will be getting a constant c. You have to find the constant c using time equal to 0. So you will be getting the integrated rate equation for a zero order reaction as k, rate constant k is equal to a0 minus a by t. After that, you have to go through the graphs using the equation by straight line graph equation you have to use. Then like this, you have to do the first order reaction. Same rate equation you have to find. After that, you have to equate it. You have to integrate it. Okay, you'll be getting a C value. You have to find the C value. Okay, and you have to take the logarithm on both sides. Natural logarithm, you have to convert it into logarithm in terms of 10. So you'll be getting last equation as this one. Okay, so this is the integrated rate equation for first order and second order reaction with their graphs. Very important. Okay, yes. Now what you have to do is I will give you some important tips. Okay, yes. So for a zero order reaction, first of all you have to find half life. What is half life? T half. We call it as T half. First of all, I will help you with the zero order. How to calculate the zero order reaction half life. For finding the half-life, you have to write down the rate equation for zero order, right? Integrated equation is like in terms of A, we will write A0 minus A by T. This is the integrated rate equation. And what is half-life? It is the time. It is a time. Half-life is a time in which concentration of the reactant is reduced to 1/2 of its initial concentration. Concentration is reduced to its 1/2. That is half-life means. So we know this is the integrated rate equation for the zero order reaction. Okay. When time equal to T half, okay, so what will be the final concentration? So that will be initial concentrations half of initial concentration, right? So we know A is equal to A0 by 2. You can substitute this in this equation. You will be getting K is equal to A0 minus, instead of A you can write A0 by 2 by T. So I'll be getting 2A0 minus A0, that is A0 by 2 2T. Okay, so T is becoming T half. So you can write this formula. T half is equal to A0 by 2K. This is the equation to find the T half of a zero order reaction. And you will be getting an idea that T half of T half of a zero order reaction is directly proportional to initial concentration, and T half is inversely proportional to the rate constant for a zero order reaction. Okay, zero order reaction. Very important. Okay, and we will do like this. We have to do the half-life of first order. Okay, T half of first order reaction. First order. Okay, so what is our equation for first order? K is equal to 2.303 by T log A0 by A. This is our equation. When T is equal to T half, that means the concentration has become what? A0 by 2. Then substitute in this equation, you will be getting what? T half is equal to 2.303 by K log A0 by, instead of this A you can write A0 by 2. 2 will go up and A0 cancel. You will be getting what? T half is equal to 2.303 log 2. Log 2 is what? There is a particular value for log 2. Log 2 over K. You will be getting the last equation. T half for a first order reaction is 0.693 by K. Here from this equation it is very clear that T half for a first order reaction is inversely proportional to rate constant, and T half for first order reaction is independent of initial concentration of the reactant. Initial concentration. There is nothing, right? Initial concentration, it is independent. So these type of questions are usually coming for the exams. Okay, how this T half, about the T half of first order reaction, second order reaction, zero order and first order is very important because it is usually asking in the exams about T half calculation, etc. Okay, so you must be very clear about the equation. You have to study. No need of studying all things by all things like forming the equation, like just study the equation, last equation, so you can the write down the formula. When the question comes, you have to directly apply the formula. Okay, yes, now let us do some questions. Okay, 1 second. Okay, consider this question. The reaction, the first order reaction, first order, so reaction is given, first order reaction is 75 percentage complete in 16 minutes. Okay, 16 minutes. How much? Okay, how much time will it take to complete 50 percentage? Okay, this is the question. So it is given the first order reaction. And what is the equation for first order reaction? K is equal to, okay, K is equal to what? K is equal to 2.303 by, time is given how much? 16, right? 16 log initial. We have to take initial as 100 and now it is 75 percentage complete means what? 100 minus 75, that is now it is 25, right? Yes. So we'll be getting log 4, right? So we'll be getting K is equal to 2.303 by 16 times log 4. So you get the value of K, right? Using this value of K, you can find how much time it will take to complete 50 percentage. Okay. So 50 percentage is what you have to find the time there. So time is equal to 1 by K. That is 2.303K. 2.303K log initial 100, 50 percentage means what? 100 minus 50, that is 50. That is 1 by 2. Okay. 2.303 by what is K? We got the K value here. K value has what? 2.303 by 16 log 4, right? You can substitute that here. 2.303 log 4 over 16 and times what? Log 1 by 2. Okay, this is log a by b. You can write log a minus log b by substituting, by cancelling all these, and you will be getting the answer for this as time is equal to 8 minutes. Then I will help you with one clue for this. If it is a first order reaction, I will give you some equations. You can directly apply that equation. You will get the get the T. If it is T 75, you can find 75 percentage complete. So it is 2 T half. What is that meaning? 2 T half. If it is T 90 percentage, that is 3.3 T half. If it is T 99 percentage, that is 6.6 T half. If it is T 99.9 percentage, that means 10 T half. So if you study this equation, when this type of questions comes, you are very simple. You can easily find this. T 75, 90, 99 and 99.9 percentage. You will be getting corresponding T half value. Constant value, you have to find just the T half, right? If you know the time, you can easily find what you can find. You get the right constant, you can easily find this. Okay. Now I'll give you one simple question. Just it's a challenging question, and you guys have to find the answer for this question. You have to upload in the comment box. Okay. Yes. Simple question. You have to find the number of half lives. Okay. Half lives required for a first order reaction to achieve 87.5% completion. Okay, you have to find number of half-lives required for a first order reaction to achieve 87.5% complete. Okay, just I will give you some clue. You have to find out the number of half-lives. Okay, initial just take it as 100. So T half means what? 100 is converted to 50. And again T half means what? 25. Again T half means what? 12.5. Right? Okay. Now if you again take T half, it will become half of 12.5. Like that. Now the answer is clear in this. And I want you to comment the answer in the chat box. If it has to achieve this much completion, okay, then how many T halves are needed? And I will give you some options. Option A 4, option B 3, option C 5, and option D 2. Okay, so please try to answer this question and put your answers in the comment box. Let me see your answers. Okay, yes. Hope you have enjoyed the video, got some idea about how to write down the integrated rate equation for the first order and zero order reaction. Also for the half-life equation for zero order and first order reaction. Thank you so much for watching. If you enjoyed this video and found it helpful, don't forget to give a thumbs up and share it with your friends. Leave a comment below if you have any suggestions or few questions. Okay, and I would love to hear from you. And if you're already sure, make sure that you have subscribed our channel, hit the like button, okay, and bell icon. Okay, stay curious, keep learning. We will see you in the next video. Till then, bye. Thank you.